on your 25th birthday, you start a job with a starting annual salary of $40,000 a year. Let's say that your annual taxes are going to be 25% of your salary. And that's going to include federal taxes, state taxes, Social Security, Medicare. So your after-tax income is going to start at $30,000 a year. And let's say you're going to get an annual raise of 4% each year. And we'll say that the inflation rate is 3%. So your raise is going to be a little bit better than inflation. And on your savings, the interest rate that you can earn on your savings, that's annually, is 6%. Okay, so you're going to save for 45 years and then 5 years and then retire. How much money will you have when you retire? So how much are your savings going to be when you retire? Well, you're saving once a year, and the amount you're saving is growing, and you're earning a constant interest rate. So you have annual payments with an interest rate and with fixed growth, and that is equivalent to an annuity, a 45-year annuity with growth, or a growing annuity. We have a formula for a growing annuity for the future value of the growing annuity. That's what we want to know, is what the annuity will be worth when you retire. And that formula is C equals 1 plus the interest rate to the number of compounding periods, that's going to be 45 years, minus 1 plus the growth rate, also to the t power. All of that is divided by interest rate minus the growth rate. And I'm going to post a video to the course website that shows how some of these annuity and perpetuity formulas are derived. So what's C going to be? Well, C is your first payment, which is going to equal 20% of your after-tax income. So your annual income is $40,000. And you're paying 25% in taxes, so that leaves you with 75% of that. And you're going to save 20%. And that means that you're going to save $6,000 the first year, and that amount is going to grow every year. So we want to know what the future value is of an annuity where the first payment is $6,000, and the interest rate is 6% for 45 years. The growth rate is 4%, also for 45 years, and that's 0.06 minus 0.04, and that is going to equal $2,377,031. Quite a lot of money, but let's put that in terms of today's dollars. So to get in terms of today's dollars, we're going to want to discount by the inflation rate. So we've got 2,377,031, and it's all divided by 1.03, and again to the 45th power. And that is $628,579. It's still quite a bit of money, though not as much as 2.3 million. Now, when you retire, you decide you're going to live for another 25 years. 25 years. So you were 70 years retired, so you're going to live until 95 years old. And you want to have a constant income in terms of your buying power, you want to get the same income every year. So you want to buy an annuity that's growing at the rate of inflation. And you want to buy that annuity with your $2,377,031. And if we put in our formula for an annuity, that's where C is going to be the payment you get at the end of the first year. So we're simplifying things a little bit. We're sort of assuming you pay all of your bills at the end of each year. That makes things a little bit easier. And the formula then is C minus R minus G times 1 minus R plus G over 1 plus G divided by 1 plus R. And that's going to be to the 25th power, because you're going to live for 25 years and then conveniently die. So that's going to be C equals, well, we have the same interest rate on what you earn on your savings. And now the growth rate is going to be the rate of inflation, because basically you want to get the same income in terms of buying power every year. So that's 1.03, 1.06 to the 25th power. And if you solve that for C, you get C equals $139,238. Well, how much is that compared to, that's what you get in your first year in retirement. So how much is that compared to what you earned in your last year of working? Well, your last year of working, you earned, well, we can figure that out, because your first year you earned $40,000, and it grew by 4% for 45 years. So that's times 45. And it actually grew for 44 years, because the first year you got paid $40,000, and then it grew for 44 more years. So that meant that your last year you got paid $168,495, which means that the first year retirement income divided by last year of working income is 82.6%. Not too bad. And if we were to put that retirement income, so let's figure out first your retirement income in today's dollars. Okay, so it's going to be 139,238. That's what that first year retirement income is. And that's divided by the rate of inflation, and that's going to be to the 46th power, because you get that first payment 46 years from today. And that is $35,747. So you started with an income of $40,000 today, and in retirement your buying power is going to be the equivalent of $35,747 a year. Not bad, but not excessive. Now, of course, we've made some simplifying assumptions in this calculation, and we've also ignored a couple of things that you might want to consider. So give a little thought to, what have we simplified, what have we ignored, and how would these change the calculation, or at least in what direction would they change the calculations?